Hi guys, this week's experiment is melting point. So before we begin, please go ahead, read the introduction in the provided lab manual and try to understand the basic concept of this experiment. And I'd like to encourage you to read the textbook. You can find the melting point section, the chapter in the textbook you have. So if you need more understanding, please go ahead, read the textbook too. But pretty much all the information in the lab manual um, has everything you need to know. Okay. And unfortunately, this lab is kind of dry lab. We're not going to really watch the actual melting point apparatus we have because due to the technical limitation in recording all the experiment of the melting point, I wasn't able to shoot a video for this lab. But instead, we're going to use one YouTube video that actually explains and shows you all the experiment, the melting point experiment. And you can find the link in the lab manual. So after understanding the concept of the melting point, please go ahead, watch the video, and all the experimental data is just provided in the lab report template. So just you're just responsible to complete your report based on the provided data, the experimental melting point data. So this is just a summary of the melting point concept in the manual. So in general, pure crystalline compounds have a sharp melting point, their own melting point if they are pure. So basically it will melt completely, like from solid to liquid, over a narrow range of temperature, normally less than 1 degrees in Celsius. So when temperature reaches the compound's melting point, then the compound's physical state is going to immediately change from solid to liquid. And that's what we are trying to see through the melting point apparatus after preparation of the sample. Okay, and then if a compound possesses some impurities, then its melting point will be depressed or broadened. So for the pure compound, usually we have less than 1 degrees in Celsius melting point range. However, if there's an impurity in the molecule, then its melting point range will be greater than the pure compound. Okay. So in this experiment, we're going to measure, or we're going to test the melting point range of benzoic acid and malic acid and their mixtures. And then at the end of the experiment, you will make a graph of all the experimental melting points. So here's what we provide for the experimental data. So basically we have pure benzoic acid and pure malic acid. And their experimental melting point range is listed here, but we have 3 additional samples, which is the mixture of these 2 compounds. So 75% benzoic acid and 25% malic acid, and then the next one is 50% benzoic acid and 50% malic acid, and then again 25% benzoic acid and malic acid 75%. So what you need to do is, the lab manual already explains that all you have to do is you just have to plot these melting points. So look at the graph. In the bottom x-axis, we have percentage of malic acid. On the top, we have percentage of benzoic acid. So benzoic acid percentage on the left side is 100%, and malic acid percentage on the right side is 100%. So when you plot this graph, look for the percentage of each sample and just plot their melting point range. You can just simply take the lowest the temperature value from the range and then just plot them. So then here on the benzoic acid, the 100% was obtained as 121 to 122. So you're going to just plot somewhere around here, and then benzoic acid 75% and malic acid is 25%, which is going to be this line here, and its melting point range started at 103. So I'm going to just plot at around here, 103, and just keep going. 50-50%, 102, which is 50% here, and then 25% benzoic acid and 75% malic acid. It's going to have about 111. So temperature 111 is going to be around here, and then pure malic acid 100% starts melting at 134 and completely melts at 135. So plot. So after plotting all these 5, the lowest value of the melting point range of the 5 compound, then all you have to do is just manually connect them. And that's all you need for the lab report. And you just want to discuss about the effect of the impurity in the melting point measurement in conclusion. So that's pretty much it. It's nothing really tricky or difficult part in this experiment. Okay, and again, I apologize that I wasn't able to make a video for this experiment because I don't have the right cameras for that melting point apparatus. Okay, so that's all I have. Please enjoy this lab and see you guys after the spring break.